Hello, and welcome to another episode of Starting Out with Quantum Computing. My name is Lloyd, and today we have a topic that I'm very excited to discuss with you all. It is, and I'm sure you might have heard of it before, quantum AI. Is it hype, or is it a near future for us? So, inevitably, we always hear people, they're talking about merging some of the strongest technologies together. But are there any grounds to do this with quantum computing and AI? Can we live in a world of quantum AI? So let's talk about the advent of artificial intelligence. So our current technological landscape is evolving at an accelerated rate. And let's go back a bit in time. So in 1950, the famous Alan Turing released a paper known as Computing Machinery and Intelligence. And it was the idea that machines could think, that they would be able to perform thought, or at least simulate the way that we think. And namely, Alan Turing developed the Turing test in order to quantify computer intelligence. And this was also known as the imitation game, and is based off the film. And so it is a test of indistinguishability, one in which an external human source tries to guess who the robot is within a conversation. And the actual term artificial intelligence was not coined in that paper. It was actually 5 years later. It was coined by an American computer scientist, John McCarthy, who held a workshop at Dartmouth to discuss simulating the human intelligence on a computer. And specifically, John said that the conference was to proceed on the basis of the conjecture that every aspect of learning or any other feature of intelligence can in principle be so precisely described that a machine can be made to simulate it. So yes, the conference, the workshop that he held in Dartmouth was trying to break down how can we kind of describe and quantify human intelligence, and if we can sort of make some laws or some formula in order to describe how intelligence works, then we can get a machine to simulate it. So let's skip a bit forward in time now. So as we move towards the 1980s, AI started to mature in incredible ways. So for example, just before the 1980s, in 1966, Joseph Weizenbaum created the first chatterbot, which we know today as a chatbot, and it uses natural language processing, NPL, to make conversation. Then in 1979, the American Association of Artificial Intelligence was founded. From the 80s onwards, AI started to boom, and sophisticated techniques such as deep learning would be applied to newer intelligence models. The Japanese government in 1981 allocated over $2 billion worth of current money to a project known as the Fifth Generation Computer Project, with the aim of creating AI that could translate human language and express human reasoning. Although it was ambitious for the time and was subsequently dropped after 10 years due to technical shortcomings, it was amazing in itself. And it set a precedent as well that AI was not just a myth, but could actually become a reality. In 1997, Deep Blue was developed by IBM and beat the world chess champion Garry Kasparov, becoming the first program to beat a human chess champion. And that sent waves across the world. Now, let's move on to more recent affairs. In 2011, Apple released the virtual assistant Siri, and I think I don't need to explain what that is to most people. And from 2012 onwards, we enter the era of artificial general intelligence, AGI. And this is basically AI that's capable of performing a wide array of complex tasks. Today, large companies with AI models trained on voluminous amounts of data monopolize the AI sector. These include OpenAI, which is not so open source at all, NVIDIA, Microsoft, Google, Facebook, Palantir, IBM, the list goes on and on. And these advanced AI models are capable of maintaining realistic conversation, producing images, videos, learning new information, adapting, seamlessly translating between almost all languages, and even powering cars. And that is only a tiny amount of what AI can do. But to look at the other side, there are limitations of AI, even today. So AI require huge quantities of data and power in order to be trained properly. They are energy hungry and they consume resources like no other. And this means that huge power stations must be continually energy must be continually generated in order to feed large AI models. And AI models are so complex that it also becomes difficult to interpret their output. So there is a lack of transparency as to how they arrive from an input at a certain output. And we can refer to this sort of scenario as a black box. And that's what these AI can be thought of. They deal with large amounts of data and they process it in a way that isn't fundamentally logical. They're using high dimensional data sets. So basically they process data in a completely different way and they consider so many variables that it's hard to know how they've come to an answer. And finally, AI can hallucinate. So this is a phenomenon where the AI makes a rather simple error, and generally we can catch the AI out on this, although not always. So for example, if an AI said that 2 times 2 was 5. So can quantum computers help out in this scenario? Quantum computers are based on the principles of quantum mechanics, a field which has existed since 1900, thanks to Max Planck. And I speak about this thoroughly in my earliest article. I speak about the first principles of quantum. So if you're interested, please give that a read. But the question is, can these machines, which harness the innate advantageous properties of superposition and entanglement, enhance AI? And the answer is they certainly can, and they have the potential to do so. And actually, they already have. So quantum computers can help to train AI systems at faster rates. Quantum computers can help AI to process large amounts of data, as quantum computers naturally deal with large data sets in a much more efficient way. Quantum computers can help AI deal with classically intractable problems that are really hard to solve, such as simulating molecular drugs and new materials. These are things which classical computers currently struggle to do on their own. As well, quantum computers may improve the language processing ability of AI, helping chatbots and AI assistants to communicate in more efficient and less costly ways. And the benefits kind of go both ways. AI-based routines can help make the user experience of a quantum computer much smoother. Right now, it can be very difficult to know how to operate a quantum computer, especially at the lowest level. It can speed up the calibration required for quantum systems, and it can mean that fewer people are needed to run a quantum computer. Equally, quantum error correction relies upon classical software known as decoders that can identify qubit errors and fix them. The most precise decoders use AI. And a final improvement to mention is a process known as transpilation. AI will help to design smart transpilers. So a transpilation is the act of converting high-level quantum circuit instructions into the native gates of a particular quantum system. In other words, it translates the quantum circuit that we want to run into the actual limited operations that a particular quantum computer can perform. So let's talk about some notable examples of quantum AI. So NVIDIA's Accelerated Quantum Center, NVAQC, is dedicated to bringing us closer to a world of quantum advantage, a world in which quantum computers can outperform classical ones at most tasks. And they believe that one of the challenges standing in the way of quantum computing currently can be fixed by involving AI supercomputing. Their powerful AI-powered supercomputers will help quantum computers by scaling quantum computers to useful sizes and qubit numbers. They'll correct quantum errors, such as bit flip and phase flip errors. They can hopefully simulate new designs for quantum computing hardware, and they can help to develop hybrid quantum algorithms. And these are algorithms that rely on both quantum computers and classical computers. And D-Wave, another company, are also pushing for wide-scale adoption of quantum AI machines. They are particularly focused on using quantum annealing, this is a particular type of quantum computing, to help customers build energy-efficient AI. This could be advantageous for businesses and for researchers. So in this case, they're planning on using quantum computers to aid the training and the development of AI. And they actually have some examples of teams using their quantum AI resources. So the first example is a research team in Germany used D-Wave's quantum technology to develop a machine learning platform to predict protein DNA sequences. And to give you a little extra context, machine learning is a kind of subset of AI that is used specifically in cases where we want the artificial machine to improve by giving it data to continually improve with. A second example of using D-Wave's quantum computers and AI resources is Canada's Particle Accelerator Centre, TRIUMPH, used D-Wave's quantum computers to simulate the high-energy particle accelerator interactions. This could then be applied to an AI model in order to improve the accuracy of its subsequent predictions. After all, an AI model is only as good as the data that you feed it. And finally, a collaboration between Honda Innovation Lab, Tohoku University, resulted in an efficient method of using D-Wave's quantum computers to generate high-quality training data for a certain type of neural network AI known as restricted Boltzmann machines, and RBMs for short. And these RBMs are very, very specific, but they're an AI that learns and predicts data based on the similar neuronal mechanics that works inside our brains. And so I would highly recommend taking a look at the video that I've linked for that. So let's wrap it up. In conclusion, quantum AI as a field is still incredibly young, yes. There have been some remarkable efforts of which I've only really scraped the surface of. I think that such a combination of quantum computing and AI is inevitable and that we should embrace it. Useful quantum computing will naturally rely upon classical systems and classical routines. It is almost impossible with today's technological structures and our current society that quantum computing will exist and function completely on its own. Therefore, an AI-assisted process will naturally come to the aid of quantum computing. And likewise, quantum computers will solve and reveal solutions to incredibly complex problems, which can in turn enhance the understanding and performance of AI. As the future unfolds upon us, let us be optimistic. There are so many incredible applications that this treasure trove of potential could bestow upon us. We could create novel medicines, we could simulate drugs that could change the medical landscape to cure tricky diseases. We could slowly reverse the damage of climate change by implementing very energy efficient routines for power stations and that were devised by quantum AI. And the list of benefits is endless, and I, for one, want to see how far it can go. Thank you very much for listening to Starting Out with Quantum Computing. My name's Lloyd, and I hope to see you next week. If you enjoy this content or the articles, please consider sharing with a friend. Until next week, bye-bye.